Course overview. The evolution of sculpture has entered an era of profound interdisciplinarity where traditional tactile methods harmoniously coexist with algorithmic, virtual, and data-driven processes. In this module, you will deeply explore the integration of traditional hand-sculpting techniques with advanced digital modeling, bridging craftsmanship with computational precision, from the chiseling of marble to the manipulation of polygons, from wax casting to 3D printing. This module investigates the transformative synergy that defines 21st century sculpture. You will analyze workflows combining manual, analog techniques with cutting-edge computer-aided design, 3D scanning, parametric modeling, and virtual reality VR sculpting environments. Additionally, ethical considerations, material experimentation, and creative problem-solving will be at the core of this exploration. This module prepares you to function as hybrid artist-technicians, capable of navigating both material and digital realities. Learning objectives. By the end of this module, you should be able to understand and implement advanced modeling techniques using both traditional and digital tools. Evaluate the strengths, limitations, and aesthetic outcomes of different modeling approaches. Transition physical sculptural sketches into digital 3D models and vice versa. Utilize software like ZBrush, Blender, Rhino, Fusion 360, and Adobe Substance 3D. Operate and integrate digital fabrication tools, including 3D printers, CNC machines, and laser cutters. Critically assess how technology influences the creative process and sculptural language. Preserve the integrity of hand-based artistry in the era of automation. Traditional modeling mastery. Traditional sculptural modeling involves a deep understanding of additive techniques, clay, wax, and plaster modeling. Subtractive techniques, stone, wood, or soapstone carving. Casting processes, lost wax, Sire Perdue, mold making, slip casting. You will be trained in anatomical modeling, surface refinement techniques, gesture sculpting, maquette creation for larger works, scaling models via proportional systems, key tools, wire armature, loop tools, rasps, clay knives, rubber and silicone mold materials, polishing compounds and patinas, introduction to digital modeling tools, understanding core 3D modeling concepts, vertices, edges, faces, meshes, polygons, NURBS versus, polygonal modeling UV mapping, and texturing digital sculpting versus, parametric design, primary software tools introduced, ZBrush, digital sculpting with intuitive interface, Dynamesh and detailing brushes, Blender, open source powerhouse for mesh modeling, retopology and sculpting, Rhino 3D, industrial and architectural modeling with mathematical precision, Fusion 360, engineering-based modeling, parametric and mechanical sculpture, Substance 3D painter, high-fidelity texturing and surface painting. Workflow integration, from clay to code. This section focuses on hybrid workflows, analog to digital, photogrammetry, converting real-world objects into digital 3D assets via photography, 3D scanning, laser-based scanning to digitize physical sculptures, reverse engineering, digitizing broken or historical artifacts for restoration or reprinting, digital to analog, 3D printing from filament, FDM to resin, SLA, and powder-based SLS techniques, CNC milling, subtractive process with automated carving machines, laser cutting, flat-layered sculpture or modular assembling. Benefits, efficiency in prototyping, precise replication and editing, infinite scalability, cross-medium translation, clay to mesh to print. Surface design and material simulation. Digital sculpting tools now simulate clay deformation, textile behavior, skin, pores, and wrinkles, metal, stone, and organic surfaces. You will learn custom alphas and brush creation, decimation and normal map baking PBR, physically based rendering, workflow painting, and material layering for realistic finishes. Balancing aesthetic with algorithm. Technology brings automation, but also risk of generic outputs. over-reliance on symmetry and precision, detachment from intuitive handcrafting. You will be trained to use digital tools as extension of the hand, not its replacement. Retain artistic spontaneity while leveraging algorithmic power. Recognize when to sculpt traditionally for emotional expression. Virtual, mixed reality, and AI in 3D art. Cutting-edge topics include virtual reality sculpting, Oculus Medium, Gravity Sketch, augmented reality installations, generative AI, and machine learning. Style transfer, pattern generation, interactive sculpture, using sensors, motion tracking case studies, Refik Anadol's AI-based generative sculptures, Google's Tilt Brush and Quill VR painting tools, mixed reality galleries, troubleshooting and exporting for fabrication, practical knowledge of fixing mesh errors, non-manifold geometry, holes, normals, file formats, OBJ, STL, FBX, PLY, optimizing for slicing software, wall thickness calibration and supports, understanding print bed limitations and machine tolerances. Capstone project direction. You are expected to design a hybrid sculpture combining analog and digital techniques, document their workflow, present technical challenges and aesthetic solutions, showcase final work physically and in virtual 3D space. Conclusion. The future of sculpture does not lie in choosing between traditional and digital, it lies in mastering both realms. The sculptor of tomorrow is a technician, philosopher, coder, artisan, and visionary. In this module, you're not only learning new tools, you're redefining what sculpture means in a time where touch and technology blend into seamless creation.